today we are moving on to evaluating and estimating square roots. Our main learning target is going to be the estimating portion today of square roots. And our topic, of course, is square roots. So there's perfect square roots and there's not perfect square roots. There's two options. Perfect square roots are easy enough to calculate. You just ask yourself what number times itself gives me the number inside. But the not perfect square root gets a little bit more complicated. So when you estimate, you want to identify the two perfect squares it lies between. So you want to identify the two perfect squares that it lies between inside. Make sure you're completing these notes. And then you want to determine which one it is closer to. And then you write down an estimate. So you identify the two perfect squares that lies between. You check to see which one you think it's closer to and write down an estimate. So here's how I handle this. The square root of 32. What two perfect squares does the square root of 32 lie between? Okay? Right, it lies somewhere in between here that I can't see very well. So it lies between the square root of 25 and the square root of 36, right? This is 5, this is 6. And then I make a little mini number line. Which one is it closer to? The 25 or 36? What's it closer to? 36. It's 4 away from 36 and 7 away from 25. So I'm about right there. Now I write my estimate. I'm going to say approximately 5.7, 5.8, I don't know, somewhere around there. It's an estimate. An estimate means you can be a little off. That's okay. And then I like to check my work. I like to see how close. It's like a game for me to see if I can get it really close. And the square root of 32 is actually 5.7. 5.65 is rounded to 5.7. So yay me.
Wait, how did you just find 5.7 for that?
Because what I did is I identify the two perfect squares. It lies between the perfect square of root of 25 and the perfect square root of 36. The square root of 25 is 5, square root of 36 is 6.
Yeah, but what do you divide 32 by?
I don't divide it.
Then how did you get 5.5 on the calculator?
5.65 on the calculator. I just did the square root. I pushed the square root button on the calculator. And the square root, and that calculates it. Okay, so square root of 20. The square root of 20 lies between these two numbers, the square root of 16 and the square root of 25. The square root of 16 is 4. The square root of 25 is 5. So I know that this is somewhere between 4 and 5. Now, where does it stand between them? It's 4 away from 16, 5 away from 25, so it's kind of like right in the middle, isn't it? Maybe like 4.4. It's almost like halfway between them. So I would call this like 4.4. Okay, so my next example is the square root of 90. So I look to see which perfect squares is the square root of 90 between, and I see it's between the square root of 81 and the square root of 100. So it lies between the perfect squares of 81 and 100. And I know the square root of 81 is 9, the square root of 100 is 10. I then make my little mini number line, remembering that right in the middle, this would represent like 9.5. And I place my approximation there. So I'm 9 away from 81, and I'm 10 away from 100. So I'm pretty much halfway. I could call it right before the halfway mark is what I would do. So like 9.4, I'd even call it 9.5. I would take 9.3. Those are all good approximations of the square root of 90. Okay, our last objective for today is to apply estimating to order the rational numbers. So ordering any rational numbers is a huge standard. It's a huge 7th grade and a huge 8th grade standard. The first thing you want to do is estimate any square roots or fractions. I want to turn everything to a decimal. Now you don't have to. It's the easiest for me though. I work best when things are in a decimal form. And then I place in order, and you always, everyone box this up. You make sure you put it in the original form. So if you changed anything, you always put it back to the original. Okay. Well, it looks like we only have one example, so I'm definitely going to give you another example. But the first thing I'm going to do is take care of my square roots so I can see what they really are. This is 2. Notice that I'm going to my perfect squares first. Well, 81's a perfect square too. And now I put in increasing order. So my smallest number is 2, which was given to me as the square root of 4. My next smallest number is 5, which was given to me as the square root of 25. And then 10, and then 15. Oh, darn it. Square root of 81, 10, 15. There. Yay me. But boy, that wasn't very hard. Yeah, so give me a second. I'm going to think of a sequence for us to order. Okay, before I order this next step, in increasing order, so 5.5, negative 0.2, negative 5, the square root of 27, and negative 1/3. I always put them all in one form so I can compare them that way. So I'm going to put them all in decimal form. So 5.5 is already in decimal, negative 0.2 is already in decimal, negative 5 is already in decimal form. Square root of 27 is not. So I need to put it in decimal form. So let's see, it lies between the perfect square of 25 and 36. This is 5, this is 6. It's super close to 25, isn't it? Yeah. So I would call this like 5.2 or 5.1 or 5.3. I know that it's super close to 5. And negative 1/3 is negative 0.3. And now I put in increasing order. The bigger the negative, the smaller the number is. So my biggest negative is this negative 5. So that goes first. That's my smallest negative number. The next smallest is the next biggest negative. And that looks like this negative 0.3. But negative 0.3 was given to me as negative 1/3. My next, well, I only have 2 more negatives, or 1 more negative, so that would be negative 0.2. And then 5.2 is smaller than 5.5. So I would write the square root of 27 there, and then 5.5. That is 8th grade level advancement. That's what 8th graders are expected to be able to do with rational numbers.